Hi guys, today we're doing edit distance. So we're given two strings called word1 and word2, and they want us to return the minimum number of operations required to convert word1 to word2. So they say we have the following three operations permitted on a word. We can either insert a character, delete a character, or replace a character. So in example 1, we're given word1 equals horse, and word2 is ROS, and we would output 3 because we start with horse, and then we want to replace the H with an R to get this. And then from here, we can remove the R to get, or I guess we're removing the second R to get this. And then from here, we can remove the E at the end to get this final result. So that's three operations that we're doing on this word. So for example 2, we're given word1 equals intention and word2 equals execution. And we would output 5 because from intention we can remove the T here to get this, and then from here we can replace the I with an E in the front, and then from here we replace the N with an X, and then so on, and then we finally get execution, and we did all of this in 5 steps. So before we get started, we already know this is going to be a dynamic programming problem. So we want to first start by defining our subproblems. So we're going to say we can let opt of I of j denote the minimum number of edits to convert word from 0 to I to word from 0 to j. Okay, and then next we can do our recurrence. So we're going to need to define our different subproblems, or like our options here, right? Like at each step, I or j. So first we can think about if the characters match, then we just get to match for free, right? Like we don't have to add anything to our number of operations, right? Because like from here, like once we got to here, like R, O, and S match this already, so like we don't need to do anything extra, so that's just given to us for free. So if characters, and let's actually like number this, so this is like option 1, I guess. If characters match, then opt at I at j is going to equal opt of I minus 1 and j minus 1. So we'll just like go diagonally in our array and just get that for free. So for number 2, we can, so they tell us here actually, we have 3 operations permitted on a word, not including matching for free. So we can insert a character, we can delete a character, or we can replace a character. So for insert, we'll say, opt at I at j is going to equal. So if we're inserting, then we are going to want to do opt at, so if we think about like, I think it's going to be I, j minus 1, and then we're going to do a plus 1, and this plus 1 is because that counts as an operation. So for delete, it's just going to be the same thing, but reversed. So it's just going to be opt at I at j is opt at I minus 1 j, and then plus 1. So everything is going to have a plus 1 except for matching, because we get our match for free. So opt at I at j for replace is just going to be the same thing here. Oops. And then plus 1, since we also need to account for the actual operation of replacing the character. So yeah, now we can just kind of get started, I think. So we'll just initialize m and n to be the lengths of these two words, so we can just not have to keep calling dot length. So we'll say m is word 1 dot length and n is word 2 dot length. Okay, and then now we want to initialize our opt array. So int opt, oops, that's not right, is new array, and then we're gonna make this size m plus 1 by n plus 1. Yeah. So now we're just gonna cover our base cases. So for our opt array, so like we need to fill out the values for like 0 from both I and j equal to 0. And so that is just gonna be I or j depending on like where we are. So like, because like for example, if we only have horse in like an empty string, then for every I, so like when I is 0, then obviously that's 0 because there's no characters. But then if I becomes like 1, it's like we have 1 character here, then if we're comparing a one character string to an empty string, then that's going to have an operation of 1 because our only option is going to be to insert or delete a character, right? So that's one operation. Like anything to an empty string is just going to be the length of the other string. So that's like going to be our base cases. So let's do that. So we'll say base cases and then, for, and we're just going to do 2 separate loops here for that. So I is 0, I is less than or equal to m, I plus plus, and we'll just say opt at I at 0 equals I. And then same thing for j, equals 0, j is less than or equal to n, j plus plus, opt at 0, what's going on here, at j equals j. Okay, so those are our base cases. Now we want to fill out the rest of the tables. So like because we already did 0 for I and j, we're going to start both of them from 1. So we're going to do a nested loop so to fill out the rest of the table. So for I is 1, I is less than or equal to m, I plus plus. And then our inner loop for j is 1, same thing. Okay, so now we're going to check our actual cases that we have. So the first thing we're going to check is if the characters match, because if they do, then we can just match for free, right? So so how we'll know if the characters match is if we'll check word 1 at or the character at I minus, hold on. Okay, should actually be -1 and -1. Okay. So we're not going to include the I and j in this recurrence. So, okay. Basically, we're going to check if the character at I minus 1 then and j minus 1 in word 1 and word 2 respectively are the same. So we'll check that. And then if they are, we'll match. If not, then we'll check our other 3 cases down here. So if word 1 dot char at I minus 1 equals 2 dot char at a minus 1, that means they match, so we can match for free, and I should have just copied and pasted this whole thing. Okay. Else, then they do not match, and we will need to check our 3 cases here. So then in that case, opt at I at j will be, and we will take the minimum of these 3 cases here. So math.min, and then in here, we are going to put this one. And then because like you can't really compare 3 separate parameters in a math.min for Java, we're just gonna compare this to the minimum of the other 2. So we'll take the minimum of the other 2 first and then just compare that to this one, and then that'll be the min overall. So then we'll do another math.min of the other 2 cases. And we'll just copy and paste here. Yeah. Okay, and then at the end, then our answer will be in the spot of opt at m at n. And that should be it. Oops, what did I do wrong? Okay, I didn't initialize this variable. Okay, there we go. So our time complexity, bro, I swear these videos would not be complete if I didn't have some kind of error. Our time complexity here, so let's think about this, right? So this is just gonna run m and n times, and then this loop, we're doing a nested loop of I. Why do I keep saying I? Oh my god, m by n times. So our time complexity is going to be O of m times n, where m is length of word 1 and n is length of word 2. And then for space complexity, so our only data structure here is our opt array, and that is storing basically m by n, or proportional to m by n. So it's just going to be the same thing. And that is it for this problem. Thank you guys for watching, and I'll see you guys next time. Bye!